And I'll get there eventually. I'm looking at buying a Mac, so this is exploring some of the different options available. Now looks like we got 3 sections for tonight. Double check and make sure. Yeah, 3 sections. We got systems, equations, and 2 variables. So let's first look at problem number 8 on page 495. And we got x plus y is equal to 1. And we got 3x plus y is equal to 7. Now, it wants us to solve this by graphing. And graphing is not a really nice way of solving these. It's not necessarily hard, but there's better ways. And I'm going to show you a better way here in a little bit. Now, in order to plug these in your calculator, you have to have them solve for y. So first thing I'll do here is take this x, move it to the right side, and I'll take this 3x and move it to the right side. So we're going to get y is equal to negative x plus 1, and we'll have y is equal to negative 3x plus 7. Now we're going to graph these. So our first one, we'll go on y1. We got negative x plus 1. So after I press y equals and press clear to clear our wherever's on that line, I'll do a negative x, this is the x key, plus 1, down arrow, and then negative 3x plus 7. And then you press graph. Now your answer on these is where they intersect. And the reason why I say this is not a great method by graphing is it's hard to see. It's hard to tell where they intersect. Now there is an easier way in your calculator. Assuming you put one of them on y1 and then one of them on y2, you do a second trace, choose intersect, number 5. It'll come up and ask you for first curve in the lower left-hand corner. You press enter 1 time. It'll ask you for second curve. You press enter 1 time. And then, assuming the intersection is on your screen, you just simply press enter on guess. And it comes back and tells us our answer is 3, negative 2. So that's our answer to that problem. Just take a look at looking for one that's a little harder to solve for y. Number 10 is harder to solve. We got 3x plus 4y is equal to 5. And we got x minus 2y is equal to 5. Well, on both of these, we need to solve for y, so we can put in our calculator. So we got 3x plus 4y is equal to 5, and x minus 2y is equal to 5. Now here I'll take the 3x and move it over. So we get 4y is equal to negative 3x plus 5. And then I'll divide everything by 4, so I'm going to get y is equal to negative 3/4 x plus 5/4. Now this other one we want to solve for y, and I see there's a negative in front of the y, so I'm going to take this negative value over to the right side, and I'll take the 5 over there. It doesn't matter which side you take it to, but when you take anything across your equals, the sign changes. And this becomes a positive 2y. And then we'll divide everything by 2. Now remember there's an invisible 1 before the x, so that becomes 1/2 x minus 5/2 is equal to y. So we'll put this on y1, we'll put this on y2. Okay. So press y equals clear. And I got negative 3/4 x plus 5/4. Then I'll go down to y2, press clear on that. Then we got 1/2 x minus 5/2. Now again, if we were doing it by hand, we would have to graph them, and then you visually look to see where you think the answer is. 1, 2, 3, 3, -1, if I had to guess. But we can use the intersect method. If I do second trace, choose intersect, enter on first curve, enter on second curve, and enter on guess. And it tells us 3, -1. And that would be our answer. Now that's solving them by graphing. Let me clear this off. Now there's a variety of techniques they'll tell you to use in section 6.1, 6.2, and 6.3. We're going to ignore that. We're going to look at it a different way. Just kind of looking ahead here. Okay. How we're going to solve it is solving linear systems of equations using the TI-83-84. Step 1. Get everything with a variable on the left side, terms, numbers on the right side of the equals. When I say numbers, I'm talking about the constant terms. The terms with variables are variable terms. Step 2, write down the matrix and input it into your calculator. And then be sure to second mode to exit out when done. A lot of people forget that step, and you have to do that. I had a student last night forget that. Step 3. We're going to go back into the matrix menu. We're going to right arrow, and then we're going to up arrow over and over to RREF. We'll press enter on it. Then we'll go back into the matrix menu. We're going to do enter on A, and then you'll do enter again. Then step 4, if you have decimals, you're going to do math, enter, enter. Okay, let me pick one out of the book. I could even show one of those ones graphically, but let's look at number 18. We got 3x minus y is equal to 5, and x plus y is equal to 1/2. Now the instructions in the book say use the substitution method, but we're going to use a graphing calculator. The idea is that if you're going to use the TI-83, TI-84 in algebra, it's to take away the manual calculation you may have done in the previous class, in intermediate algebra, algebra 2. Okay. Step 1. Get everything with a variable on the left side, numbers on the right side. Everything with variables over here, numbers over here. That's done. Step 2 is write down a matrix. Now how we do that, your matrix is a rectangular array of numbers, so we drop our x's, y's, and equals, keep the numbers in their signs. So we got 3, -1, 5, 1, 1, 1/2. Now a matrix has a size that goes along with it. Another name for size is order, and I think there's even some problems to ask you what the order is of a matrix. And this is in rows by columns. So for this problem, we're going to have a 2 by 3. Our new puppy is in the background barking, in case you're wondering what that noise is. Okay, so I'm going to exit out, do second mode. Now we're going to go input our matrix in. We wrote it down, so after you write it down, then you input it in your calculator. Now where you go input that at, and this depends upon your model of your calculator, is you do second, push your second button, and then you push this x to -1 button. That's actually your inverse button. But that gets you into the matrix. You see above the x to -1, it says matrix. Now if you have a TID3, not a TID3 plus, but actually a TID3, you'll have a button that says matrix. So you have to do it a little bit different. Now to input our matrix in, we go over to the edit. So I'm going to right arrow twice to go over to edit, or you could left arrow once. We're always going to put it in A. If you have numbers here, that's fine. If you don't, that's fine too. You'll see why. But we'll go ahead and do an enter on A. Now you have to be under the edit. If you're under the names and you do the enter, it'll be messed up. Now it's asking us for the size or the order. And we said we had a 2x3. So do 2 enter, 3 enter. You cannot mess this up, because at this point what you have written down form-wise should look like the form of this. If you put a 3x2, it will not look like this. Now we're going to type in each number pressing enter after it. So I do 3 enter, -1 enter, 5 enter, 1 enter, 1 enter, and 1/2 enter. Now when you put the 1/2 in, it'll change it to decimal form. That's fine. It keeps track of what it is originally. Now notice that these x's and y's here did not have numbers in front of them, so we put the 1. Now if you're missing the variable completely, you'd put a 0 there for it. Okay, we just input our matrix, and remember I said to second mode to exit when done entering it. So we'll do second mode. And now we're at step 3. We're going to go back in the matrix menu. So do second, x to -1. We're going to right arrow. So our right arrow. And then we're going to up arrow over and over to RREF. So I'll press my up arrow over and over until you get to RREF. Make sure you choose the one with 2 R's. The one with 1 R is the wrong one. You get the wrong answer every time. And after you get up there, then you press enter on it. Then it tells us to go back in the matrix menu. So do second, x to -1. We're going to do enter on A. Now I'm under names, and you see A's already highlighted. There's nothing special we're doing. We're just simply pressing enter. And then we'll press enter again. Now we get decimals here. And if you get decimals, you do math, enter, enter. So you press math, enter, enter. And we get this. So this is 11/8 and -7/8. Now 2 equations and 2 variables. Your first 2x2 square here should be a diagonal of 1, 0, 0 else, which it is. If that's the case, this will be x and this will be y. If you're wondering about the order of the answers, it's the same order as our columns. We put our x values here and we put our y values here. So our answer is going to be 11/8, comma, -7/8. Now let me show one more of that type. And number 22. We got 3x plus 5y is equal to 2. And we got 2x minus y is equal to -3. Now I have put YouTube videos out there to show you how to do this by hand if you're curious. But this is how you use technology. Now all the x's and y's over here, specifically you want the x's in the same column and the y's in the same column, which they are. So I'll drop the x's, the y's, and the equals and keep the numbers in their signs. Now this is another 2 by 3, rows by columns. So let's go input it in. So I do second, x and negative 1, to go back in the matrix menu. I want to go over to edit. So I left arrow once or right arrow twice. Do enter on A. It wants the size of the matrix, so we'll do 2 by 3. So do 2 enter, 3 enter. And then we'll do 3, 5, 2, 2, negative 1, and negative 3. And then I'll exit out. So I'll do second mode. Okay. Well, now I'm going to go through my process. I'll do second, x and negative 1, right arrow to math, up arrow to RREF, press enter on it, go back in my matrix menu, second, x and negative 1, enter on A, and enter again. And we get this right here. For two equations, two variables, this first 2 by 2 square should be a diagonal of 1, 0, 0 else, which it is, which means this is my answer. This is x and this is y. So we'd have negative 1 and 1. Now I'm going to talk about the oddball cases after I work one out of the next section. Let me clear off this page. And let's look at number 6. Hopefully this is not an oddball case. I can't see the answer. 2x plus 3y minus z is equal to 1. And x plus 2y plus 5z is equal to 4. 3x minus y minus 8z is equal to negative 7. Double check all my signs. Okay. Now I say in my instructions here, solving linear systems equations. System of equations means you got 2 or more equations. Linear means everything's the first power. 2 or more equations, everything's the first power. Well, this is again RREF. So I got 2, 3, negative 1, 1, 1, 2, 5, 4, 3, negative 1, negative 8, and negative 7. Again, the idea here is you put your x values in the same column, put your y values in the same column, put your z values in the same column, and a number on the other side of the equals in the same column. Now our size of our matrix has changed. This is now a 3 by 4, rows by columns, 3 rows, 4 columns. So let's go ahead and put this in. So I do second, x and negative 1, go over to edit, enter on A. 3 by 4, so I do 3 enter, 4 enter. And then we got 2, 3, negative 1, 1, 1, 2, 5, 4, 3, negative 1, negative 8, negative 7. Now only so much of the matrix can fit on the screen at one time, but it automatically scrolls over for you. I'm going to double check my numbers. 1, 4, negative 7, negative 1, 5, negative 8, 3, 2, negative 1, 2, 1, 3. And I'll exit out. Make sure you exit out before you do the next step. And this we're going to do our REF just like normal now. So do second, x negative 1, go to matrix menu, right arrow to math, up arrow to RREF, press enter on it, go back to my matrix menu, second x to negative 1, enter on A, and enter again. Now we got decimals, so we'll do math, enter to change them to fraction. And then we got negative 5/9, 8/9, and 5/9. 3 equations, 3 variables. Our first 3 by 3 square here should be a diagonal of 1, 0, 0 else. And it is. That means it worked. That means this is x, and this is y, and this is z. The order of your variables matches the order of your columns, x, y, z, x, y, z. And we write it as an ordered triple. You put parentheses around it and put commas between them. And that would be our answer. Now the next section, 6.3, is basically the same idea. It's really nothing new there. It may tell you to use Gaussian elimination, it may tell you to use Gauss-Jordan elimination. Don't worry about any of that. When you're working these, you're just going to use RREF. So I won't show any problems out of there. There's nothing unique. But let me talk about the oddball cases, because those are different. I'm working a problem down, and I'm going to pretend I have 2 equations, 2 variables. The same idea holds true with other cases, though. If I work a problem down, and I end up with something that looks like this. Remember, for 2 equations, 2 variables, the first 2 by 2 square here should be a diagonal of 1, 0, 0 else. It isn't. So this did not work. So if it does not work, it's one of the oddball cases. And this is the first example, or the first type. In this one, notice that the last row is all zeros and a single 1. What this means is no solution. So if you try to do RREF, you get down to this point and your last row is all zeros and a single 1, means no solution. Now if I'm working a problem down and I end up with something that looks like this. 2 equations, 2 variables. Our first 2 by 2 square here should be a diagonal of 1, 0, 0 else. It isn't. Notice that to here, the last row is all zeros. So last row is all zeros, means there's an infinite number of solutions. So infinite solutions. Now just to show you one more, that's a 3 by 3, 3 equations, 3 variables. You're working a problem down. Now for 3 equations, 3 variables, our first 3 by 3 square here should be a diagonal of 1, 0, 0 else. It obviously isn't. Notice that the last row is all zeros and a single 1. Again, that means no solution. Now I would recommend, unless you're going into mathematics or computer science, that you do these using your technology, using your calculator. If you want to do them by hand, that's fine. Like I say, I put videos out there. If you watch the YouTube videos I put out there, it'll show you how to do it by hand. And it's not a horrible process by hand, but it is tedious and takes a while. And that's actually the end of those 3 sections.